Right? This is the fourth session in PySpark tutorial that we started. We can say the fourth week. So every week we are covering a few topics, and as part of that, we already covered few introduction topics, part of last three sessions. Now in this session, we want to add few more topics into introduction as well as start about RDDs. Okay. So yeah, and in going forward, we are going to discuss many other important topics, and also we'll try to do some hands-on on it. Okay. So initially I'm not giving you any curriculum, but going forward, we can add into our material. Okay. My intention is to add many topics and want to discuss many topics so that we'll get clarity in a broader way. Okay. So let me just do a quick recap for 5 minutes, because those who missed in the last sessions might not understand if we start directly. So we'll discuss first 5 minutes for last three session what we did it at a high level for 5 minutes, and next we'll try to start the topics for the day. Okay, as usual, in last few minutes we'll open for questions and answers. Okay, and this session is maybe around 30 minutes. We'll try to wind up within that timelines. Hope my voice is clear. I think we are good to go. Right? Anyone? Quick check.
Yeah,
Yes, good to go.
All right. Okay. Just give me 5 minutes to recap. So we discussed what is Spark, and we discussed features of Spark. So majorly, I told you, right, when if you face any interview question, then you're supposed to ask, you're supposed to explain the features of Spark, if why we have to use Spark. If they ask something like that, then we should explain all these important points so that they can understand that you have some idea. Okay, and core concepts we already discussed. I don't want to deep dive again, and prerequisites, I told you. These are the prerequisites we're supposed to know to learn by Spark. Okay, Spark installation guide. There's a new one that I have added. Hope many of you already downloaded and check this URL, where you can get some video from other YouTube channel where he explained in detailed way how to install PySpark on our machine, on our Windows machine especially. Okay, so please go through this one, and also I will try to include this link in our video description. Those who miss, you please click on the link and try to install on your Windows machine. Okay, guys, and then we discuss architecture part. As part of that, we also covered what is worker node and on heap memory, off heap memory, and containers, executors, and we'll discuss. If you missed this topic, please try to visit our playlist and get a knowledge out of it. Okay, and actual architecture part we already discussed in 4 parts. So these are the 4 statements that we already discussed, and in our previous video we discussed in detail. I request you to please go through the same if you still have any questions or doubts on it. Okay, so and then we discussed in our last session, that is part of 3rd session, we discussed Spark session versus Spark context, and what is the difference between these two, and when Spark session 2 was introduced, and when we were used Spark context. Okay, at a high level, you can say prior to Spark 2.0 version, we used to have a Spark context along with the Hive context and SQL context and streaming context. But 2.0 onwards, we are using only Spark session in place of all the existing context. Okay, it doesn't mean that we don't have these, but we have these which is embedded in Spark session class. Okay, so these are the topics so far we discussed till last 3 sessions. Then I want to cover a few more new topics for this session 4. and also we'll try to take up questions if you have, and then we will wind up. That is the agenda of this course, a session especially. Let me start. So guys, I think so far you might be clear. Those who are already attended, then definitely they may not have questions, but those who are attending freshly, then sometimes you may face little challenge to understand. For them, I request you to please go through our playlist. Okay, session 1, session 2, and session 3. Right? Okay, I am just keeping sessions very short so that it will create some interest for learners, and also given a short description. I don't want to waste your time and my time as well, and those who are watching this video also, it will helpful. Okay then, so today's topic is little interesting. So how to create a Spark session, already we covered this screenshot also we have already covered. So if you want to use any editor or shell, then we supposed to create a an editor. We have to create a Spark session. I can say Spark object we have to create by using Spark session. Okay, Spark session, from where we will get it? We will get it from spark.sql library. Okay, so here in a first screen or first demo here, what I'm saying here is I missed to enter the master. As I told you, we have to include master and specify whether it is a local or Mesos or Yarn or Kubernetes. Okay, so majority cases we use to have Yarn as a cluster manager. Then we will do the same. Okay, I will show you how to create a Spark session or Spark object, and also how to use the master. We'll see in this lecture. Okay, and as I told you, for development, we majority cases we will use interactive session. That is picture 2 in a screen, and where we no need to create any Spark object, because see in the last line, Spark session available as a Spark. Okay, what is Spark session is here? Spark session is a class. Spark is an object. All right. So if you see, let me open command prompt. I have already installed PySpark on my machine. I request you to please install Java 11 version and Python 3 version. Okay, please go through the video. Then whatever we given in the description, you can get it. How to install a Java, how to install a Python, how to install a PySpark. All right. So simply you can type as a PySpark and enter. Okay, it will take little time. Then it will create a Spark object for us. Okay, we'll come back here shortly. Meanwhile, just open, or shall we wait for some time? No worry. Let me open this one. So this trying to open this interactive session. It will take little time, but it will open. Okay? As I told you, Spark is an object of Spark session. Till here we discussed in our last session. Okay, that is the reason I explained little faster. Don't worry, upcoming sessions will go little slow. All right. Okay, so let me check again. See here, Spark session has been created. Spark object, this is an object of, it's an object of Spark session. Okay, right. So this is a PySpark 3.1.2 which I installed, right? And this is a UI. Okay, this is a UI. We will see what exactly the UI, how we can check the executors and job status, etc., in upcoming slides. Okay, so guys, as I told you, there is a web URL. Once we submit any application in a interactive mode, okay, then we will see some web URL for that. Okay, so generally how we can check a web URL is like this. Okay, so if you write this one, even you can check it web URL without submitting any Spark job. Okay, so it is a little important. Everybody should aware how to check the web URL and how to trace the job running status. Okay, so what we will do, sc.ui web URL, right? Let me write it. So sc is a Spark context. sc dot UI web URL. See, this is a little different for each mission. For your case, it may be a little different. Okay, so you just copy it. So we have selected, and if you enter it, then this is a Spark Web UI. Okay, so now we are not seeing anything jobs here because we didn't submitted any job. But going forward, when we submit any Spark application, here we will see all lineage or DAG. Okay, we'll see practical once we start working on the practical part. Okay, so here the stages we will see, and storage we will see, and then environment, and finally executors. Okay, how many executors it got created, or how many code that it consumed. See here. Okay, one driver is there. Here we are not seeing much information because we didn't submit any Spark applications. So my system is having total 4 cores. We are able to see 4 cores here, right? So we'll check when we submit a Spark application explicitly. If we give any number of cores or memory, that that value will reflect here, right? So that's what I just explained in this slide. If you see, this is a command that we're supposed to use in your machine. You can use the same command. You may see a little different ID. Okay, HTTP, and the balance URL is might be a little different, but port is 4040. Okay, so obviously when you take it and paste it in your browser, then you can see similar kind of page. Okay, so it's quite easy but important. Okay, and coming to the next one. So we've been discussing about the Spark, right? So why we should use Spark, and what is the actual importance of the Spark? So earlier, right? Earlier, in Hadoop we have a MapReduce for, though it is a parallel processing, but it is very much slower, and writing a code is a little challenge in MapReduce, right? Basically, we have to write a Java code. It will execute on a disk, so it's not that much fast for huge data, right? So in place of that, we Spark came into the picture, and it is, we already discussed, Spark is 100 times faster as compared to MapReduce in memory, and 10 times faster as compared to MapReduce in disk. Okay, so one of the important is it also follow the distributing computing system. Okay, so if you see in normal traditional and distributed warehousing or computing, then traditional is centralized. Okay, you can say that is vertical. Okay, if some resources we supposed to add, some storage supposed to add, then earlier we used to have only a vertical mechanism, but when distributed mechanism, we are adding machines in a horizontal manner. Okay, so earlier if we load 100 or 1 TB of data, then it's supposed to store 1 or 2 machines, but whereas in distributed mode, then it will segregate and uniformly distribute in a different machines. So how we are seeing picture here. Okay, that is how the load is becoming reduced, and then when we send any code to compute, then every code will execute its own, and then it will give result to the driver. Okay, that is how work sharing will be happen here, but not in centralized mechanism or centralized system. Okay, so that is where Spark is a bit faster, or with other as compared to legacy systems. And apart from that, if you see the features of Spark, we already discussed. It's a fault tolerance and in-memory computation, and immutable, and scalability and JVM, and there are so many lazy evolution, we can say. There are many other features are there which brings Spark as a faster than any other system as at present in Bigdata world, right? So in a short form, I can say just want to walk through the code, whatever I written here text. In centralized system, all the data is stored and processed in a single server. This system holds well when the volume of data is less. However, as the data starts to increase, we need to upgrade these servers, right? To store and process more data, this concept of vertical scalability, where we increase the capacity of existing hardware or software by adding resources to the existing system, is not possible beyond a certain point. Okay, we can add, keep and add, but once we reach some level, then that is very difficult to add few more nodes in a vertical system. But whereas in distributed mode, then that's when distributed system came into a picture, where huge amount of data is split across multiple systems and processed in a distributed manner. Okay, so this is called distributed computing, and Spark is one of the open source framework for distributed computing. Okay, so this is a backup. If somebody asking you why should we use Spark, then you can explain this also as part of Spark features, right, guys? It's quite simple, but good to know, right? And so ways of executing of Spark application, I already told you we can execute majorly in two ways. One is through interactive shell. Just now we have seen what is the interactive shell. Second one is to execute script directly, okay, on a cluster. Interactive mode you know very well, but the script mode or how we can execute a Python file or PySpark file is we will see practical going forward. Okay, so if anybody asks you modes of submission, then you're supposed to say these two modes. You can submit your application in two modes. That is mode means you don't understand that way, like cluster or client mode. No, I'm not talking about that. This is the application where we submit. Okay, we can submit in interactive shell, or we can execute our jar files or files in a like script mode. All right, and coming to RDD. Here from here, right, we used to have a actual topic. You can say you should understand. By the time those who have already have a knowledge and Spark, then definitely they might have a good experience in RDDs as well as data frames. But just if you have already have a knowledge, then please try to brush up. Okay, for them it is a revision, and for others it may be useful, right? So we know what is a RDD is a resilient distributed data set. Resilient and distributed data set. You know the meaning resilient, long lasting, you can say. Okay, and distributed is a we are distributing entire code or data in emissions. Okay, data set is a data. All right. So PySpark RDD or RDD both are same. Okay, is a fundamental data structure of PySpark that is a fault tolerant, immutable, distributed collection of objects. Okay, so fault tolerant, I told you fault tolerant is something when we lose or transformations in between, then it automatically retrieve it based on its lineage. Okay, for that cache or persistence it will use. Okay, and immutable, once we create any RDD, we cannot change. Okay, we can create one more RDD with your whatever you want to change, you can do that changes and then create a new RDD, but not in existing RDD. That is called immutable. Okay, we cannot change that. So which means you can create an RDD, you cannot change it. Okay, each dataset is an RDD is divided into logical partition, and we can compute it on different nodes on the cluster. As I told you, if the file is more than if we are using underlying storage as a Hadoop, then it is a 128 MB is a block size. Obviously, it will create a different partition based on the data size. Okay, So RDD is a very simple definition. You can say if anybody asks how to create an RDD. We can create RDD from 3 ways, but I can consider only mainly 2 ways. The third way is people will say we can create an RDD from another RDD. I don't know. I didn't understand what exactly is that. Okay, we can create an RDD from RDD, that we know very well. But why should we discuss that is a separate thing? Okay, so that is the reason I'm just explaining here only 2 methods. That is by using parallelize. Okay, in order to create an RDD, first we need to create a Spark session, which is an entry point to the Spark application. And Spark session internally creates a Spark context that we know very well. All right. See, how can we create a Spark object? This is the way of creating Spark object, right? So earlier I just told you, right, in the beginning of the session, I missed to write master. Here, please try to understand in real time also, we will write this code. Okay. Spark is a Spark session.builder and master in place of master. When we are working in our local machine, we supposed to give local of 1 core or 2 core, 3 core or 4 core, but don't give entire cores because 1 or 2 cores might be used for our system OS. So better use 1 or 2 cores if you have a 4 cores. All right. And app name is a name of our application. Why we should give app name is because of in a cluster, right? Not only for our application, many other applications will also run, right? If something goes wrong, then how will you debug? And there should be some name, right? Like how we have a separate names of each person. So for each application also, we should give some unique name so that we can able to trace it. Only for that purpose, we supposed to write app name. Okay, we can set configuration. Also, here I didn't mention because I mentioned already in our previous slides. And then finally get a create. This is the syntax, guys. This is very important in interviews. Definitely people will ask you what is the syntax to create a Spark application, Spark object from Spark session. All right. These are looks like basics, but yeah, important. So final topic for today's session is just I told you, right, ways of creating RDDs. We have a few ways. Out of 3 ways, I think I brought 2 ways which are important, and generally we use these methods only to create a RDD at first time. That is using parallelize method. We generally use parallelize is, I can say, for a development side we will use parallelize, but not in a real time. Okay, this is the syntax to create an any RDD. Let me go back and open. See, this is a session, right? This session is already there. Spark is already there. See here, Spark is already there, right? But just assume we are not working in a interactive mode. Then what we will do? We will create this one, right? So what I will do? I will just like this. We will create. Okay, like this we will follow in real time. Then now Spark object is created. Then what next? Let us say this is the data set. Okay, this is the data set is there. This is the list of records. Okay, what we can do? We will create one RDD. Very simple. Spark context. Okay, Spark context we should write it. Okay, because Spark context is a part of Spark session, right? Or Spark object, right? That is the reason we should write it. And then parallelize method. Okay, it's quite simple. Since it is a beginning, I'm just showing this, but going forward, we'll try to do few more hands-on on RDDs. Okay, don't worry. Then when you want to see, then ultimately you can write action that is collect. Also you can use it, but in production you don't use collect. Okay. Okay, spell mistake. Huh? So this is the one way of creating RDD. Hope you understand the way of creating RDD. And next one is simple. It is from a file, right? So from a text file, how we can create a RDD is very easy. Okay, so we'll just use the same way in place of parallelize. We will use text file. All right. So in text file, you can give any text file format. So what I did for your demo, I just create a small file. This is the RDD.2 file. Okay, whatever you can give it, but try to understand Spark RDD is not a structured one, right? If you want to see data in a structured format, then you should use Spark data frame. So I have, I taken this path. The file is here. Okay, file is here. I taken this path and I pasted here. See this. So try to make a note. When you copy this path, right, while you are working in a Windows, if you see, backward slashes. Okay, but if you use directly same like this, then it won't work in Windows. You have to replace with a forward slash. Okay, try to note this point. This is the path. Then let me copy and that's it. So it's very simple. In our projects, right, we don't use much RDDs because RDDs we can use only when we process unstructured data or semi-structured data. But if we are working on a OLTP applications or batch oriented, or you are trying to get the data from any RDBMS system into your Hadoop, then that time there is no use of to create a RDD. Directly we can create a data frame out of it. Okay. So, but we supposed to know. We don't know, right? Some people may work on OLAP applications or OLTP applications. I can say streaming applications. Okay. So basically, OLTP applications are the applications streaming related, and OLAP is the batch oriented. Okay. So yeah, that's it, guys. For today's, I didn't cover much, but yeah, I think we'll go slowly. No need to worry. But I want to cover few more hands-on by using Spark RDDs. We'll try to solve any use case by using RDDs, or we will do some transformations in our next session by using RDDs and get a command on it. Okay. I think we have another 8 minutes left. If you have any questions, I'm open. We'll try to discuss. Yeah.
Can you describe more about this parallelize? I mean, in the sense, how internally it works. I mean, if you give parallelize, is this the data split into multiple clusters, and then we are collecting that, or?
Let me tell you one thing. Actually, okay, knowing in detail, it's very good idea. But try to understand parallel is a inbuilt function. Okay, inbuilt method in a Spark. Correct. So if you work on a large data set, then you come to know how it got parallelized. Like whatever we are giving input as a data set, how it got divided into multiple partitions, how it got parallelized. Then you come to know. So here, for an example, only I have just written some, list and then showed you in a correct syntax. But for your case, you can, play with a big data set and try to use parallelize and see output again. Also check the get number of partitions. Okay. So, and then you come to know how it got, how it is doing a segregations, or how it is doing a parallel processing in a backend. Okay. But I'm telling you, right, in real time, as per my knowledge, we are not using it all. Not required, first of all, for batch related applications. Okay.
Okay.
Nobody will ask you. Nobody will ask you. So far, I didn't ask that questions. I didn't see if anybody is asking what exactly internally this parallelism will do. But instead, people will ask you what will happen when you submit an application, or they will give you, so let us say 1 TB file. Then they will ask you how many partitions will create. Okay, or how many executed that you're supposed to give. So these kind of questions you can expect, not this type of questions. Okay.
Okay, sir.
Yeah, no problem. Guys, any other? If you have any questions.
Yeah, hello.
Yeah. May I know your name?
Rahul Patel. Actually, my first day of this session
No problem,
means
Rahul.
your session.
No problem, Rahul. Tell me.
Actually, question is not related that topic, but question is how we trigger this Spark job.
How we trigger? Okay, Spark job, right? We will see that. Okay, you know, right? So this is we
Hmm.
just started. This is a fourth session, but going forward,
Okay.
we will see how
Hmm.
we can submit Spark job in practical. Okay,
Hmm.
you don't need to worry about
Okay.
it. Yeah,
Okay.
we will do some hands-on on it. Ultimately, our goal is to execute the job only, right? Definitely, we will discuss that.
Hmm.
Yeah, hi
And
Naresh. This is yeah, yeah. Please
Your
go ahead.
name? Yes, yeah, Rahul or
yeah,
somebody.
yeah,
Yeah.
and you said in parallel method not use real time. So which method mostly use in real time?
Text file, text file.
Okay.
Yeah, yeah. Next one.
Yeah, Naresh. Hi Naresh.
Yeah.
Satish here. This one.
Yes, Satish.
Yeah, Naresh. So about this course, right? So it's a general question, not related,
No
nothing
problem.
too technical.
No problem.
So like in any list of topics that we are going to cover for the next few weeks, do we have something like that? And what about the Python? And
See, sorry, you want to learn Python first of all?
no, I'm just asking like generally because it's a PySpark, right? So you
Mhm.
need to have a good knowledge in the Python as well.
See, when we are started working on PySpark, then definitely we should have at least a basic knowledge on
Okay, okay.
Python, right? So without no basics, you cannot work on PySpark.
Okay, about that, yeah. So can I see this course as like very in depth or
See, let me tell you, that is the reason I'm not disclosing any curriculum as of now because
okay,
this won't be ended very short. Okay, because
okay,
this topic will keep on add. Okay, first what I
okay,
will do is the plan is first of all I will try to cover the topics which are very important. Okay, both interview point of view already as well as in real time point of view. Okay, once we cover
okay.
that, once we do some transformations or hands on, then what we will do, we will try to resolve some use cases based on my experience also. Okay,
Oh yeah, yeah.
I will
Okay,
discuss or I will try to explain to you based on my previous experience which we
yeah,
did
yeah.
it in
Okay,
our real time. Okay,
okay, okay.
so
Yeah,
this is not never ending, we can say. Okay, we'll keep on. Let us say if we
okay,
have any use case,
okay.
we will try we
Uh,
will try to resolve it, and
sure, sure. Yeah.
that will add it into this curriculum so that people who are referring this documentation will get a whole idea.
Okay,
Correct?
okay. Yeah, yeah. Definitely yes.
This is there is
So
no fixed curriculum here. Okay, we'll try to add as many as topics with real time example.
okay,
Okay.
yeah, yeah, okay. And one thing I want to add, like finally, because I started following this channel long back, and this is my like first session
Mhm.
because I've had earlier also I
Mhm.
attended few sessions and I think you are doing a really great job, and
Thank you.
I truly appreciate that. Thank you so much. Yeah.
Thank you, Satish. Thank you, guys. I can take one more question. Only we have 2 minutes left for this day.
Hi, Naresh.
Yeah.
Hi.
This is Ram here.
Yeah.
Uh, Sorry. Yeah, not related to today's topic,
Mhm.
but in Hive we have option to change the execution engine to Spark,
Yes, of
right?
course.
And
Yeah.
also in Spark components we have Spark SQL, I mean
Mm.
Spark SQL.
Mm.
So how different these two?
See, you asked very, very good question. Might be you can expect this kind of questions also, but try to understand. So ultimately, Python is also working on Java, JVM, right? Ultimately, Python is also using Java Virtual Machine, right? So all code, whatever you are writing in a PySpark or Python, are converting into Java, then it is executing, or Scala, then Java, it is executing. The similar way, even you are using a Hive or SQL, then ultimately the syntax will supposed to convert it into native language. Okay, you can use that, but might be little latency you may find out. Okay, but you won't see that difference in a smart data set, but you may observe that kind of latency in a huge data set. Okay, but you are good to use anyone. All right, you can use SQL as well in a Spark. Okay.
Okay.
But apart from that, you're supposed to integrate Hive with the PySpark. Then only it will work. But when you work directly on Spark, you no need to integrate anything. Directly you can work on it. So some third party or some integration supposed to do some configuration files. You have to set it to work with a Spark with Hive. Okay. But if you work directly on PySpark, then we no need to do anything. Okay. Hope this might be clear. Thanks for asking questions. If you people have any questions, please try to note down in a comment section. I will try to answer it. If not, we will discuss same thing in a next session. Guys, as time is up, thank you so much. Have a nice weekend. Take care. Thank you.
Thank you, Naresh. Thank you.
Thank you, Naresh.
Thank